When there is common, something common, then how to apply this axiom of union, which is nothing but the addition theorem. Understand it please carefully. Addition theorem is based on the axiom of union only. So addition theorem is P of A union B is equal to P of A plus P of B minus P of A intersection B. Why should it be P of A intersection B? If you see through the Venn diagrams, it is sample space S, this is A, this is B. If I say, and this is A horizontally, this is B vertically, this is nothing but A intersection B, then if I write axiom of union for this one directly, like P of A plus P of B, what will it be? What happens? These two are not disjoint sets. You cannot apply that. The reason is, when you take P of A and written here, and plus P of B and written here, this is counted twice. It's clear. It's counted twice. That is why it is subtracted. Very simple. That is why it is subtracted. What is intersection? Common area. Common area is subtracted. This is nothing but the addition theorem on probability. Okay. Now, let us see the problems based on the classical definition on probability before going to the next part, which is the conditional probability. Okay. See the first problem now. 6 married couples are standing in a room. 6 married couples are standing in a room. Couples, you know, doubles. It is 6 into 2, 12. 12 persons are there. And if 4 people are chosen at random, then the chance that exactly one married couple is among the 4 is exactly one married couple is among the 4 is. So, whenever you attempt any problem in probability, don't forget to write the total number of outcomes. If you are clear about the total number of outcomes, then you can pick out your favorable number of outcomes. So, before solving any problem on probability, don't forget to write the total number of outcomes, or in other words, exhaustive events, or it is nothing but the sample space. So, from now onwards, I'll be using this. P of A is equal to N of E upon N of S. Probability of an event A is nothing but number of favorable outcomes to A whole divided by total number of outcomes in the sample space. Total number of outcomes, simple. So, N of E upon N of S. So, before writing the probability, let me write first N of S. What is N of S? The total number of outcomes. How many people are there? 6 married couples are there. 6 married couples means it is 6 into 12. 12 people are there. From 12 people, how many people are chosen? 4 people are chosen. Choosing is nothing but, and I want to tell you, the choosing or the selection is nothing but a combination. It's nothing but a combination. Arrangement is nothing but a permutation. So 12 people are there. From 12 people, 4 are taken. It is 12C4. It is 12C4. The total number of outcomes will be 12C4. 12C4 means all the 4 may be males, all the 4 may be females, and 2 may be male, 2 may be female, and 1 may be male, 3 may be female. Like that, many number of combinations may be there. The total number of combinations are 12C4. But what is a restriction given there? Among the 4 people chosen at random, then the chance that exactly one married couple among the 4, you must have only one married couple. So how many married couple are there? 6 are there. 6 are there. So what I do, I'll tick. That is, I'm writing N of E now. This is N of S written. That is denominator written first. N of E I'm writing. Now what I do, because I need only one married couple. There are 6 married couple are there. I'll choose 1 from 6. I have chosen. It's the first operation I'm performing. I've been repeating. Whenever you are solving the problems based on permutations and combinations, and now probability, always split the problem into operations. You will be more comfortable in solving the problem. So first operation, what I performed, I have chosen one married couple from the 61 did. And what should be the second operation? Second operation, I need two more. I need two more. So how many are remaining now? How many are remaining? Here, one couple is taken from 12, 2 are taken, 10 are remaining. From 10, I'll take 2. Alright, this one is nothing but a couple. So 2 are taken. Total, how many persons are there? 12 persons are there. From 12, I have taken 2. How many are remaining? 10. But I have taken only 2. I need 2 more. That is why those 2 are taken from 10. So 10C2. But what happens? Among this 10C2, you may be getting 1 male, 1 female, 2 males, 2 female. Like that, different combinations you may be getting. But I need only exactly one married couple. This one only I need. So what I don't need, second married couple, I don't need that combination. So because one married couple is already chosen, how many married couples are remaining? Only 5 are remaining. Those 5 I don't need because I have already chosen. So this 10C2 contains, because it is 2. The 10C2 contain, there are possibilities of getting again a married couple which we don't want. That is why that is to be subtracted. What is 5C1? Because from 5 married couple I can choose 1. So that is subtracted because we don't want that. First operation performed, second operation performed, and these 2 operations one after the other simultaneously can be performed in 6C1 into 10C2 minus 5C1, which is nothing but 6 into. It is 10 into 9 upon 2. It is nothing but 5 into 9. Nothing but 45. I'll write that directly. 45 minus 5. Which is nothing but 6 into 40. It's nothing but n of E. Therefore, P of E is equal to n of E upon n of S. I have already written the formula there. So it is nothing but 6 into 40 upon 12C4. You can simplify that. And while simplifying, don't apply the factorial. Never apply. It will be waste of time. So because suffix is 4, write only 4 factors. 12 into 11 into 10 into 9 upon 4 into 3 into 2. Reverse this, reciprocal of this, simplify, you will get the required probability. So, what the approach in solving the problem is important. What is the approach? I taught you. First of all, don't forget to write the total number of outcomes. After writing the total number of outcomes, think of the favorable number of outcomes. Favorable number of outcomes are like this. We need only one married couple. We have taken already. And how many should be taken? Again, like 2 persons are to be extra to be taken. From 10 remaining 10, I have taken 2. But this 10C2 contains again 5 married couple. There are chances of getting married couple again, but I need only exactly one married couple. That is why I have subtracted it, and this will give you a favorable number of outcomes, and favorable number of outcomes divided by total number of outcomes will give you the required probability. Okay, go to the next slide. There are 4 defective items in a lot consisting of 10 items. From this lot, we select 5 items at random. How many items are chosen? 5 items are chosen at random. The probability that there will be 2 defective items among them is. Understand that, please. Understand that carefully. Now, let us write. The formula is one and the same. P of A is equal to N of E upon N of S. I need the total number of outcomes, N of S. How many items are taken? How many total number of items are there? First of all, you see that there are 4 defective items in a lot consisting of 10 items. So, how many total number of items are there? 10 total number of items are there. How many items are taken? 5 items are taken at random. Go through the problem, please. See the problem. Read that. So, 5 are taken. Total number of items are 10. So, from 10, 5 are chosen. So, 10C5. That lot is consisting of 10 items, and from 10 I have taken only 5. It is 10C5. Now I have got the total number of outcomes. From this one, what we need is there is 4 defective items in the lot and 6 non-defective items. 4 are defective and 6 are non-defective. Let us suppose there are 10 apples. Among 10 apples, 4 are bad apples or rotten apples and 6 are good apples. Now, how many ways the apples can be chosen? There can be total number of outcomes will be 10C5. This 10C5 may be contained, you may get all the 4 bad apples like rotten apples, and you may get 1 rotten, 4 good. You may get 2 rotten, 3 good. Like that, different combinations you will be getting, the total number will be 10C5. But here the question is the probability that there will be 2 defective items among them is. He needs exactly 2 defective items. So how many defective items are there? You can go through the beginning of the problem. 4 defective items are there. From 4, how many can be chosen? How many should be chosen? We need 2 defective. For C2, first operation performed, that is restriction fulfilled. And how many are remaining now? 5 are taken. So among 5, already 2 are taken. How many are remaining? 3 are remaining. How many are remaining? 3 are remaining. Those 3 must be non-defective. Those 3 must be non-defective. How many non-defective are there? How many non-defective are there? 10 minus 4, 6. So from 6, you have to take the remaining 3. First operation performed in 4C2 different ways, getting 2 defective items exactly. And second operation getting 3 non-defective items from the 6 non-defective items. Second operation performed. Principle of counting, that we multiplied. So this is a favorable number of outcomes, and the total number of outcomes are this. Therefore, let me say this as A. Never mind. This is P of A is nothing but 4C2 into 6C3 upon 10C5. You can of course simplify this directly. Improve mind calculation instead of applying the factorials and all. Improve mind calculation. 4C2 is nothing but 4 into 3 upon 2. 4 into 3 upon 2 means 2 into 3. 6 into 6C3 is nothing but 6 into 5 into 4 upon 6. 6 is getting cancelled. 5 4s are 20. Upon 10C5, what I said, you have to write 5 factors starting from 10. 10 into 9 into 8 into 7 into 6. And denominator comes to the numerator 5 into 4 into 3 into 2. If you simplify this, you'll be getting required probability. In a similar problem, just to try this similar problem, how it can be seen. Please go forward. In a batch of 10 articles, please go through that. It is your homework. In a batch of 10 articles, 4 articles are defective. 6 articles are taken from the batch for inspection. 6 articles are taken from the batch for inspection. If more than 2 articles in the batch are defective, the whole batch is rejected. Whole batch is rejected. You find the probability that the batch will be rejected. Of course, it requires little more knowledge, but try that because you have already learned the concepts in the board level. You can try the problem. What is it? A batch of 10 articles, 4 articles are defective. In a similar way, 4 articles are defective means 6 articles are good. Then the 6 articles are taken from the batch for inspection. How many are taken? 6 articles are taken from the batch for the inspection. If more than 2 articles in the batch are defective, from the 6, if more than 2 are defective, then the entire consignment will be cancelled or rejected. So what is the probability of rejecting the consignment or that articles? Okay, try this. We'll be doing more and more problems in the next class. Keep watching CAP TV.